Let me just be sure that my mic works. Okay. Hi, guys. So, in this stream, we are going to be learning recursion in Python. I have learned recursion before in the past, but it's never really stuck to my head again. And I'm also trying a new format where I get to learn with you guys. So, this would sometimes be streamed on my Twitch, sometimes be streamed on YouTube, sometimes to be streamed on both platforms. So I've got my jotter here with me, a pen to write things down. But before we start, I would love to share this online. Try to get more people to join. Uh, yeah, yeah. So uh, let me just share this. Let me screenshots and then I share. Uh, okay. Mm, learning recursion in Python life. Link below. And recursion life. So I'm like super nervous, like very, very nervous to do this because I'm not used to learning in public or doing this. So I am very, very shy. I am. I am very, very shy. But hopefully I get to become more comfortable in this format. I get to do more of this and get to learn more of this too. Mm. So, in case you're just joining, you can let me know where you're joining from. We have not started yet. I'm still trying to share this online. I'm still trying to share this online and push this, just get more people to hop here and join me, I guess. Um, so, mm, oh, bear with me. I'm just trying to share this out there. Okay, it's been posted on LinkedIn and posted on Twitter. All right, so let's start. So today we are going to be learning recursion in Python, and I have a bunch of articles that I want to. Well, not a bunch. An hour before this stream because I literally came up with the idea less than 2 hours ago. So an hour before this stream, I was going through a bunch of YouTube videos and YouTube shorts on recursion, and I got to realize recursion it's like an infinite loop. Recursion is like an infinite loop where okay. So recursion is like an infinite loop. Yeah, it is an infinite loop. So I am not that great at talking. So bear with me if I repeat a lot of my words. So in today's stream, I have like the agenda on my phone. In today's stream, we are going to be looking at what is recursion, why do we use recursion, how to use recursion in Python. Is recursion really an infinite loop? Because As I said, I was going through a bunch of videos, and someone said that recursion is not really an infinite loop because your laptop or your machine or whatever machine that you're running that recursion script on, at some point it will stop. Um, it would stop, I think, because of uh, co- cause of a call stack or something like that. So, yes. Hi, Francesca. So that is another thing that we're going to be looking at, and then I would be doing some real world examples of of recursion. So I'll be using an article to go through what recursion is. Like I said, I have my notebook here. I'm going to be writing that down too. And then when I go through the article, when I have a better understanding on that, I will try to implement my own example of what a recursion is. So I would be spending less time looking at the comments and looking at the chats because it's going to be a bit um tedious for my brain to be switching between, oh, let me check the comments, let me read the article. So there. Fran, I said, love the style. Hope you can cut out some part and make into a video. Yes, I hope I can. And unfortunately, I forgot to start recording. So uh, I guess I would download the video much later, try to cut it up and use it in like use that and convert it to a full video. Yes, and yeah, I did notice that I'm becoming better at recording. Is this the first time you're trying this format? Yes, it is. This is the first time I'm trying this format. I've seen a bunch of other creators do this, mostly on Twitch. I haven't really seen much of it on YouTube. And then Francesco's Dev Mode News, like his live stream where he gets to demo AI tools, was also what inspired me to do this. Like, it's a fun way. It's a fun way for me to do this. At least I get to talk about a, a tool I like, which is Python. Then I get to talk. Then I get to learn online, like not just learning and it's confusing me. I get to learn with you all, and then another thing is I get to improve my communication skills. I really do not know how to communicate or teach stuff very well, but yeah, this is all part of the learning process. So recording would be better, but you can also download the video. Yeah, I think I would have to open up my OBS to record that because I'm kind of using the free version of Restream. I don't. We never stop experimenting with platforms. If you strictly talk about Python, I think YouTube makes sense of it. Yes. So I'm trying to. Yeah, it looks like OBS is trading the power because I noticed that I was fluctuating a bit. But yes, I'm trying to experiment with my content and while I want to stick to Python for at least 1 year, I'm still trying to explore Python in different fields. So Python in DevOps, Python in web development, Python in AI, Python in machine learning. I think I had 3 streams on Python in machine learning. That was really amazing. I had one on DevOps, and I'm having another fun one this Saturday with Francesco, and we're going to be looking at Python, Docker, and Rust. So yeah, I guess we can just start the stream right now. And then another thing is I'm trying to go beyond 1 hour. A lot of my streams are 40 minutes to an hour. That's personal stream where I'm sorry, a solo stream. It's 40 minutes to an hour, but I'm trying to go beyond that, push boundaries. But yeah. Okay, so let me. Hi, Anthony. It's really really nice to see people join me here. But I I am a bit excited. Oh wow, I really cannot wait for that. I mean, for me, for if you really want to get my attention, just mention Python, and I'm just like this. Yeah. So just like how if you want to call Batman, you have to use the bat signal. If you want to call me, you have to mention Python. And I'm really happy that my videos were very helpful to you, Anthony. Thank you very much. Okay, so let's get into learning. In case I miss your comment after a while, I will check the comments, but I would focus more um, on what I am learning. Okay, looking for a better. I'm looking for a better format for this. Let's move this here. Is this really visible for you guys? Because I don't know if it is. And Anthony said he's learning OOP, and yes, so when I was learning Python on my own, OOP was something that I skipped. Like it was a bit difficult for me to learn what it was back then, and I skipped it for some reason. I really don't know how I would know much on OOP, but that's fine. Okay, so let's us get started. So first of all, recursions. In case you um, want to follow along with the article, I will be adding it in the comments, but also be but I would also add it in the video description. So if at any point it's not that visible for you to see, do let me know. But yeah, let's continue. So recursion is, according to what we all know, or anyone that's ever come across recursion, we all know that recursion is an infinite loop. It's where a function indirectly or directly calls itself. And yet it says that it calls itself to solve a problem by breaking it down into simpler and more manageable parts. While recursion can solve a problem, recursion can also make your whole code buggy. Okay, and apologies for the ads by the side. Gigs for Gigs is just a platform that I really really like to um, use as a guide. So that is what recursion is. And yeah, it says that in Python, that's this part. It says in Python, recursion is widely used for taxes that can be divided into identical substack. So for people that don't know what a loop is, because recursion is an infinite loop. For people that don't know what a loop is a way for you to repeat a task or for you to iterate over a sequence of a lists, or I think a tuple. So it's a way for you to iterate over a bunch of values or objects. And now recursion is an infinite loop. Furthermore, it explains here that in Python, a recursion function is defined like any other function, but it includes it to itself. The syntax and the structure of a recursion function follows the typical function defined in Python, with the addition of one or more conditions that lead to the function calling itself. So this is an example of a recursion, and it's coldly explain what it says here, where it said that a recursive function is like any other function that calls itself. And here we have a function called factorial. And what this function does is it says that the number that has been defined as the parameter, if the number is same as 0, return 1. But if it's not same as 0, multiply that by this function, the number the number passed as a parameter subtracted by 1. And if we run this, we should be able to see. And if you run this, you should be able to see 120 if you give it 5. So you can copy this, go to this place, share this tab instead. I am using onlinede.com. It's an online code editor. I did not want to be switching from Windows to Windows, so I just had to use an online code editor. So if we change here to, let's say, 2, what this does is, of course, this is not true. Like the 2 is not equals to 0, so this would not this action would not be executed. Instead, this action would be executed. So it's going to do 2 multiplied by 2 by the function of 2 subtracted by 1. So if we run this, we should see 2. And this is how a recursive function goes. It's defining the function here and calling itself within its own function. So this is how a recursive function works. I don't know if I fully understand it, so I would keep reading more. So now the explanation of the code, it says that the factorial of the number n is the product of all the positive integers less or equals to n. The recursive approach involves the function calling itself, that is where it calls itself here, calling itself with a decremented value of n until it reaches the base call of n. Oh, sorry, I just realized that I wasn't showing this screen. But yeah, the explanation says that the factorial of the number n in this code example is the product of all the positive integers less than or equals to n. The recursive approach involves the function calling itself, which is how it calls itself here, since this if statement was not true, involves calling itself with a decremented value of n. This is the decremented value here until it reaches the base case of 1. So this should explain what this is doing. So I fully do not grasp the explanation, but from my little knowledge on Python, what this is doing is it's taking a parameter n that it was later defined as 5, and it's saying if 5 is same value as 0, return 1. But since 5 is not same value as 0, then it says in the next line, return 5 multiplied by the factorial of by the function, and in this n here replace it replace the n with 5 subtracted by 1, and here it gave us 120. But in this example, when we played around with 2, it gave us 2. So let's see 10, and it gave us 3,000. Sorry, that's give us 362,000. No, this is 0. Okay, 3.6 million to 88000. So that was what. So if we now change this factorial to 0, think it should give us 1. And yes, I was correct. So that is the basic example of factorial. Now, in this table of contents, it shows that there is a base case and a recursive case. There are types of recursion which I never even knew existed. There's a difference between recursion and iteration, advantages and disadvantages of using recursion. Let me look at the agenda to be sure that, okay, so now we know what recursion is, and let's look at the basic, the base case and the recursive case. So this is the basic structure of a recursive function, where you have your function and your parameter, and then you have your statements, your if else statements, and this is the base condition, or this is the first condition. And after this base case condition, you have a base result, and then we have an else. That's if this does not work, do this. And the else statement returns the recursive function and a modified version of the parameter. So going back to this example, and using going back to this example and using the basic structure in mind, it says it has the function, it has the base case condition, and it has the modified the function and the modified the modified parameter. Okay, I was going to play around with this, but let's just go back to the article, because I am still a bit confused. But let's continue. So now we have the base case, and I actually forgot to write that down. Uh, Recursion in Python. Structure, where it has function parameters, base condition, or the base case condition, anyone, and then return the base results. Then the else will return a, the recursive function, but with a modified parameter. So that is the syntax. Now let's look at base case and recursive case. So yeah, it says that this case is the condition in which the recursion stops. So it is the condition to prevent the infinite loop and to ensure that each recursive call reduces the problem in some manner. And this is the base case condition. This is the base case condition. So if this is met, then the infinite loop is stopped, or the recursive function is stopped. This, like, would I call it a fail safe? Like, just so you do not crash your system. Then the recursive case is the part of the function that includes the call to itself, which is the else statement here, the return statement under the else. So it calls itself, it must eventually lead to the base case, In the factorial example, the recursive case is to return n multiplied by the recursive function and a modified parameter, that's 5, or whatever value of n you pass, that value subtracted by n. So it also shows another example of recursion or a recursive function. And in this example, this is the first base case and this is the second base case. And what this is saying is if n is same value as 0, return 0. If n is same value as 1, return 1. Then this is the recursive case where if these two conditions are not met, then we do this. We are going to return the recursive function and the modified parameter of n plus the same cursive function and the modified parameter as n subtracted by 2. So I'm going to use ChatGPT to give me another much more basic example of recursion, because I'm still not like I get that that recursion is an infinite loop that loops through, but I feel like the code examples may be confusing me more than I admit. Uh, Give me a code example. Example of recursion in Python. I'm gonna go back here, delete everything here. So it's technically giving me the same thing. So it's giving me the same code example. Okay. You know what? I'm going to try to write my own version of a recursive function and see if I actually get it. So the structure says that I have to write the recursive function. So def new function, and in here I'm going to pass a parameter h. And then it says that I need to give it a base condition, and the base condition can be more than 1. So I can say if h is same as the value 2, uh, return, let's say h l if h is same as the value 5, return 5. So return h. Else, then this is where we can do the recursive case, or the recursive statements, where we say else return the function with a modified parameter. So we can say h plus 1. Something missing here. Okay, h multiplied by this plus 1. Oh, and I forgot to call the function. So we're going to call function into this. I want to print it. So print new function, and let's give it two first. So it's going to meet the first condition. It's going to return two. So if we change it to 5, it's going to 5. It's going to return 5. But if we change this to, let's say, 4, so what this should do is 4 multiplied by function of 4 plus 5. I think I should give this 20. I think what I'm trying to understand is this, like the mass behind this. So according to ChatGPT and the article, it says that it evaluates as this recursive state. It evaluates the value given, which is 4 multiplied by it should be 5, 6, and then it's, sorry, math is sometimes difficult for me. Oh, I see. So what it just did was it's returned this 4 more multiplied by 5. I'm sorry, 4 plus 1, which is 5. So 5 multiplied by 4, and it gave us 20. So this is how you can call a recursive case. So it's more like you using your own function within your function, and it keeps looping. So that is it. Now, this is another case of how you can use recursion in your code. I'm sweating a bit. I'm really nervous, but yeah. So it says that you can also use recursion in Fibonacci, where there's base case and another base case, and then the return case. So if we pass, okay, since we are passing 10 here, what this does is 10 subtracted by 1, which is 9, plus 10 subtracted by 9 subtracted by 2, 7. It doesn't make sense again. Okay, so it says the function calls itself twice with the decrement of the value, summing up the results of the call. So this division into smaller sub problems continue until the base case is reached. Oh, I see. Okay. I think I'm now getting an understanding of what recursion is, or how to at least write a recursive case. Okay. All right. So now let's look at the types of recursion, which I never knew until I saw it in this article. It says that recursion can be divided into two types. We have the tail recursion and the non-tail recursion. The main difference is the main difference between them is related to what happens after the recursive case. So in a tail recursion, it occurs when the recursive case is the same operation executed in the function with no additional work or calculation following the recursive call. Um, it also says in many programming languages, tail recursion can be optimized by the compiler into iterative loops to improve performance and prevent stack overflows. So then non-tail recursion occurs when there are operations or calculations that follows the recursive call. So this prevents the compiler or the interpreter from optimizing the recursion into iteration. This is an example. So in this tail recursion example, there's a base case, and if this base case is not met, the recursive call is the action within the recursive call is executed, which is what we have been seeing as code example. So that is what you call a tail recursion, where after that operational or after the action in that case, that's after this is executed, there's nothing else that follows after. So this is like the final bus stop. Then in the non-tail factor, it says that where operations or calculations follow the recursive call. So it says that here, this is the base case. The non-tail recursive, because the multiplication happens after the call. Oh, I guess. Okay, so this is the difference. Um, in this example, of the recursion, we in the recursive case, we noticed that there was a calculation before the function. This calculation, this multiplication follows the recursive function, and this is what you would see as a non-tail recursive function, and it's mostly used to prevent your interpreter from turning this recursion into an iteration. But in case where there is no calculation there, like this is your recursion code. This is yes. In cases where this is your recursion, no, let's change it to, let me just see if I'm doing the right thing. Okay, yes. So in cases where this is your recursion code, where there is no calculation outside of this function, that's what you call a tail recursion function. And according to the article, it says um, is mostly used to tell your compiler or your interpreter to optimize the loop to prevent any performance. And here it says, okay, and here it gave an error. It gave us a recursion error that says recursion depth exceeded into comparison, because we needed to have done some sort of calculation within the parameter or within this bracket. So if we do okay, no, that's correct. If we want to do that, we'll just have to change this to, let's say, yam, and then um, yam plus 1 or yam plus h. And let's define yam as, let's do 5 and define yam as 1. Let's see if it doesn't get there. 5. So this is actually this is how you can define your tail function. So remember, the tail recursive function is like this, where there is no calculation outside of this recursive case function. But if there is a calculation outside like this, yeah, multiplied by this function, and then this is what you call a non-tail function. Wow, that's very, very cool. Very, very cool. Okay, so let us look at the difference between recursion and an iteration. So yeah, it says that recursion is easy to interpret when the problem is naturally recursive, like a tree traversals. And then it also sets that recursion leads to solutions that are easy to understand compared to iterative ones. Then iteration involves loops like the for loops and the while loops to repeat a block of code over and over and over again until either a condition is met or until the loop is broken. And iteration is generally more memory efficient as it does not involve the multi-stack frame compared to recursion. So two things that or three things, yeah, three things that I have identified from the difference between recursion and iteration is number one, recursion is good for, well, it's just good um for, let's say you want to use less memory on your laptop or your machine. It's better to use iteration than recursion because recursion would use a lot of memory space compared to iteration. Secondly, is iteration are mostly your for loops. They are mostly your for loops and your while loops, and recursion is more like your base condition that has a first base condition, a second base condition. So I'm guessing that recursion is more about if, else, and elif statements embedded within the function, and iteration is more like for loops and while loops. And thirdly, it says that recursion it's best if the problem that you're trying to solve is naturally recursive. Now, if you don't know anything about data science or algorithm, like me too, it's fine. Just it's fine. I mean, learning takes time. So, because I genuinely do not know what traversals are, but I'm going to search it and I'm going to find out. So it says that um, tree traversal, also known as a tree search or walking the tree, is a form of graph traversal that refers to the process of visiting, that's retrieving, updating, deleting each module in a tree data structure. So it's like doing the CRUD function. Sorry, not the CRUD, the CRUD that's creates, reading, updating, and deleting except the C is not there in a tree data structure. And I did learn about a tree data structure once. So, like how a tree is a tree that has different branches. I think that's what a tree data structure is. Let me just search that so I do not say the wrong thing and get cancelled. Okay, yes. So I was almost right. Like how a tree has different branches and different so on. Like a family tree where you have the mother, the father, the kids, the grandkids. So um it says that a tree search is like the process of visiting those branches in the trees one by one. And it says here that recursion is good for when you want to visit that type of data structure. when you want to, when you are solving a coding question that involves that type of data structure. That's where you get to use recursion, and iteration should not even cross your mind at that point. Okay. Oh, oh, thank you very much. Thank you very much. Because this is actually the very first time that recursion actually clicked for me. Okay, so let's look at the advantages of using recursion and the advantages of using of not using recursion. Yes, recursion is fun, it's good, it's nice, but it's not really good for you to use recursion a lot. And coming from these facts where it says that recursion takes more memory space in your GPU or CPU, but it takes more memory space. So I'm thinking the memory overhead. Yes, I was right. Memory overhead is part of the disadvantages of using recursion. But let's look at the advantages of using recursion. First of all, simplicity. So it says here that recursion code is generally simpler or cleaner, especially for problems that are recursive in nature, like the tree data structure I just talked about. In that type of scenario, using in that type of scenario, using a recursion is best. I mean, it's better than using an iteration. And then it also says that recursion can reduce the length of the code since the repetitive tasks are handled through the repeated function like this, where I necessarily don't have to be calling this function over and over, like how I would have to do this print, or to call the function over and over again. With recursion, I just have to call it only once within my function, and I just wait to get the output that I want to get. So these are the two advantages. I'm very, very sure there are so many other advantages, but these are the two advantages to recursion. And now to the disadvantages, I said this earlier, that's memory overhead because it uses so many memory space. So each recursive calls add a new layer to the stack. So every time your code makes a recursive call, like in this case, every time it hits this recursive case, it's like adds more layer. So let's say this is the base, it adds more layer, more layer, more layer, more layer, more layer, which increases the memory. So it's like an empty book, and each time you write on it, like you decide to write one line. So each time you write one line here, write one line here, one line here, till you write on the whole page. So I think that's what it's meant by memory overhead, because it adds a layer of stack every time it makes the recursive calls. And next, it said performance issues. It says here that recursive functions may lead to slower responses due to overhead. Yes. One thing that I have come to know is that every time um, your code or your program uses a lot of your memory, it tends to be slow. So as your recursive call is adding more layers, as it's adding more layers or adding a new layer in each call, it also affects the response. So you will be getting a slower response because, I mean, more layers are on top. Yeah, more layers are on top, and it's be a bit harder for your code to give you your return statement or your return output, compared to an iteration where it just loops through it, pick out what you want, loop through it, pick out what you want, and it doesn't necessarily have to add an additional layer. And lastly, it says that risk of stack overflow. So excessive recursion can lead to stack overflow. I will not lie, the first time I saw the stack overflow, I thought they were talking about the website itself. But yeah, it said it leads to stack overflow error if the recursion depth exceeds the stack limit. So this error, there was an error that we had. I think it was it this error? No, it was not this. It was not this. I can't remember the error exactly, but we did have an error. Uh, enough parser. Okay, I remove this. Let's see, 19. Yes. So yeah, where we had an error, I said the maximum recursion depth exceeded in comparison. Oh, sorry, I just remember that I was not showing this code. But yes, so if you have this type of recursive function and you run something like this, you will definitely have an error. And the article says that the error can, when you use excessive recursion, it can lead to an overflow of new layers of stack, which would give you an error that is very similar to this that says the maximum recursion depth exceeded. So I would love to also know what a recursion depth is. So I'm just going to search it real quick. So yeah, it says that a recursion depth refers to the number of times a function calls itself before reaching the base case or the maximum limit allowed by the programming environment. It essentially measures the nesting level of the recursive function calls, and each recursive calls add a frame to the call stack and the maximum number of the stack frames. So in summary, a recursion depth is the number of times your function can call itself before it reaches the base case. And the base case in this code example is this first case that we define here. And that was why it's hinted at the error at this base case. So yeah, that is why you should use recursion and why you should not use recursion, and the environments that you should use recursion and the environments that you should not use recursion. Okay, so the article has finished, but there are still some things on my agenda because I am yet to learn about recursion that I would love to know too. So I'm just coming back and I'm going into this. And thank you very much for hi, pardon. Thank you for joining and supporting me. Woo! Okay, so Fran has a question off the topic, but do you know that after the live stream you can also embed, you can also use an embedded editor on YouTube? I never knew that. Okay, I never knew that, but I would definitely try it. Brother. And he says you can also do cuts, but that may be a nightmare, but still doable. Hi, Pradum. Thank you for joining. Just had the mind blowing possibility happen, but then I can share. Oh, congratulations in advance, Fran. Congratulations in advance. Oh, thank you, Francesco. All right, yeah, I will definitely check it out. Oh, and then I would definitely be in your DMs to know what awesome thing that you just did. And thank you guys for really joining. This is like the genuinely the very first time that I have understood recursion and not confused myself. And yes, we should definitely have a stream together, like all of us. We should definitely have a stream together and share each other's knowledge. Okay, so back to the agenda I have in mind. So now I now know what recursion is. I know when to use recursion, but then I don't know. Okay, yeah, I know when to use recursion. The difference between recursion. I know why recursion is used over iteration. But then I would also love to know in a real world example, why would we choose recursion over any other form of coding? So that's what I want to check now. Why should I use recursion? Why should we use recursive function? I have to say that I love the fact that every time I make a search, there's an AI overview here, and then I can still go down and still read an article. So yeah, it says that recursive functions are valuable in programming due to the ability to break down complex problem into smaller, more manageable problem, making your code more elegant and more cleaner, I guess. And they excel at handling problems with a natural recursive structure like the tree that I saw. But I wanted something more. Okay, yes. So here's a detailed look at the advantages. So we've already talked about the simplicity, and yeah, it says that it's a natural fit. Yeah, we've already talked about this, how it's best to use recursive function when you are dealing with trees or graphs, or when you're trying to do a data structure that resembles that. Yeah, it also says that it's also good for divide and conquer, where many algorithms, such as sorting, the merge sort, the quick sorts, the binary search, are based on a divide and conquer strategy. Yeah, it says reduce cognitive load. Recursion can reduce the cognitive burden. Can it? By allowing them to think about problem. Oh, yes, yes, it can. Okay. But I don't think for a regular, well, not a regular, like a junior dev, I really don't see a junior dev use um this as often as people make it out to be. I think that you may use recursion probably when you are working on an advanced or a complex project, not a simple project like this. Just my thoughts. That's just what I'm seeing it as. Because it took me a while to fully understand this, and I am a junior developer. And another thing is that I don't see the use case in this. And I don't really think a junior developer will be playing around with binary search or tree data structures. I may be wrong. I may be wrong. but I'm just saying that. So what other thing is on the agenda? Our real world examples. So when to use recursion. Okay, what's recursion and when to use it? Let's for Stack Overflow to open a bit. Ah, yes. Why don't people use recursion? Still think to answer this question is it depends on the solution that you're trying to solve. Junior developers may not necessarily need to use recursion as often as they would need to use iteration or for loops or while loops. Yeah, and then another thing is I think the memory space. So you don't use all the memory on your laptop and stuff like that. Yeah, this. Okay, so then another argument or another thing I want to find out is um are recursions really infinite loops? Because if we say that recursions um they use your memory by adding a new layer with each recursive call, are they really 100% infinite? Because I mean, all, once you've used up all the memory on your machine, your VM or your local machine, once that's once the recursive case stop at any point. So that's what I want to find out. Are recursive functions actually infinite? So yes, it says that no recursive functions are not inherently infinite. They are not inherently infinite. Um, Recursive functions can terminate and have ended, a well-defined end, just like any other function in programming. However, if a recursive function lacks a proper base case or a recursive call, it may never reach the base case and it results in an infinite recursion, which will eventually cause an error. Okay. So it's saying that it is infinite, but it's not infinite at the same time. Because I mean, once it causes an error, then it has stopped. So it's no longer infinite. Or am I just reading so much into this? I think I am. Yeah. So it says though, no, it's not inherently infinite. So as long as your recursive function can your recursive case can meet your base case, then it's not infinite. But if you don't have a proper base case and your recursive case cannot reach the base case, then it results in an infinite recursion. But then it also says that when it results in an infinite recursion, it will also cause an error. So I think this has to be the the debate in my head of the week. Are recursions 100% infinite or not? So yeah. Again, I said if you can never reach a base, it would go on to make recursive calls forever and the program will never terminate. This is also known as an infinite recursion. It's generally not considered a good idea, of course, because because of a lot of things. I mean, your program is running forever, the amount of memory it's going to take, and so many other factors that I really cannot think of right now. It says that in most programming environments, a program with an infinite recursion will not really run forever. So they are infinite, but depends on the environments that you run them on. Ah, I see, I see, I see, I see, I see, I see. All right. So I guess this is everything that I have on recursion, or this is everything that I wanted to talk about on recursion. I really don't have any other topic in mind. I would have loved to push the stream for 2 hours, but I really don't have any other thing in mind. But thank you, everyone, for joining. I was really, 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 really able to finally understand what recursion are. Finally able to understand that. And yeah, I plan to do the stream once a day for as long as I can. Um, Probably more than a week, where I will get to talk about one topic. And if it's a topic that I don't really know about, I get to learn about it. So before today, I knew that recursion was an infinite loop. Today, I found out that recursion is not necessarily an infinite loop. And there are two types of recursion, the tail and the non-tail recursion. And a difference between a recursion and an infinite recursion, and the structure of a recursion, the base case, the recursive case, or the recursive calls. So yeah, I have been able to learn a lot with you guys. So if you have any suggestion on what I should learn next, you can drop them in the comments, and if I can, I would. So once again, thank you everyone for joining the stream. Uh, so I guess I'm done and I have to go. So bye guys. Oh, and then please another thing, do not forget to subscribe to my channel. So I'm trying to monetize my channel and trying to grow the followings. Currently I am at 200 and something. Yeah, I'm at 284 and would really love to monetize the channel in a couple of weeks. So if you can, do also subscribe and like and comment. Oh, so thank you. See you tomorrow. Hopefully the same time. But see you tomorrow. And I have no idea what I will be learning tomorrow. But I just know that I'm just going to be showing up and learning. I I really don't have like a list of what to learn. Okay, I do have a list of what to learn personally, but I really don't have a list of what to learn on a stream. Well, all I know is that I'm trying to show up, learn, engage with the audience, try to build my communication skills, and have fun while doing that. So, thank you everyone for watching. Do have a nice day. Bye.